Hello everyone. In these lectures, I am going to discuss basic computations by using Python. And then next video, I'll also do some advanced basic computations by using Python. So let us first open Anaconda, and from there we can open Python. So I click in there. From there, I click on the Anaconda navigator, and it is opening now. Okay. I click on the spider. Okay. So this is the Python. So I'm going to open a Word document, and then I want to open the written Python code, and then I will read Word document, the problems, and the problem will be solved by running the Python code. Okay, let me first go to open the Python code. I think it should be in the spring in here to basic Python code. Okay. Now let me open the Word file, desktop, W. Here is the week one. Here is the part one. Here is the part one. So I mentioned in here basic computation part one. In a section, download Anaconda and R Studio in your computer. So you do not need to install this one because we are exclusively going to use the Anaconda like in Python. If you do not know how to download, then write in Google, download Anaconda for Windows or Mac computer. Similarly, download R and R Studio in Windows or Mac computer. In first week of the class, I help each student to have R Studio and Python download in their computer. For Python, we are going to use the spyder. For Anaconda navigator, we are going to use spyder. Okay, so these are the basic 23 questions we are going to do. Subtract 1 from 2. So let me go there. Subtract 1 from 2. So this is the subtracting 1 from 2. And these three, line 1, 2, 3, these are the packages. Someone build this package, and we are going to use these things. So we have to go there, tools, preferences, and then keyboard shortcut. And in the keyboard shortcut, cell, run selection, run from lines. I want to do run cell. Here, run cell. I change it to F9 to. I want to change it. Control return, and this is okay. And then now apply, and then okay. So what was the problem? Problem was if I want to run one line of code, it was not running. and it was running the entire code. For this reason, I went to the tools, preferences. I went to the tools, preferences, and then keyboard shortcut, and then run cell. I found the run cell. Run cell, I found it, and I changed it to control return. So now in that way, you can do the same thing. Now, if you run this one line of code will run. Okay, run cell problem. So let me go there again, tools, preferences, keyboard shortcut, run cell, and advance. I want to do this. Run cell and advance. So now if I want to run it, let me see F9. Where is F9? Okay, let me do these things again. Preferences, keyboard shortcut, run cell, run cell. Enter. Let's check. Okay. So run cell, preferences, keyboard shortcut, run cell, run from line, run from line. Let's check. Okay. Again, they are running just one line of code. Now, I want to run line by line. Let me see. Tools, preferences. Run selection. Okay, finally got it. It is run selection. Okay, so there are, let me again explain why I waste couple of minutes to figure it out. I already knew it, but it is a new version of the Anaconda, and they have changed little things, so that's why I tried all the options. So from your keyboard, if you want to transfer one line of code from this editor to the console to get the output, if you want to use Control Enter in Windows Computer and Command Enter in Mac computer, you have to make a change. So you have to go to the tools and preferences and then keyboard shortcut, then come in here, come in here, there is a run selections. You will click on run selection and a window pop-ups, and then when window pops up, on that window, there is a small box. Select that box and then click control enter, hit control enter, then control return will be the shortcut key. Control return will be the shortcut key. And after that, you select the OK, apply, and then finally OK, then your things will be done. Okay. So now this is the code that I already have. I will upload this code in our first week folder. Now the line 1, 2, 3 are the packages. Some other people build it. So import NumPy. NumPy is a package that is built by some other programmer, some other data scientist, and we want to use that package to solve our problem. And short name I gave as NP. Similarly, the another package is known as the pandas. I have given a short name of pandas as PD. And then another package is sci-fi state. I give a short name as S1. So in that way, 3 packages I run. Command enter. Okay, now I want to subtract 1 from 2 and the result is 1. Here is the result. Control enter in Windows computer. In Mac computer, it should be command enter. The second problem, which is available in this Word document, add 4 and 5 in Python and R. We are just focusing on Python. So I did this, then I got a 9. And then how to multiply 2 numbers. This is the way 2 numbers could be multiplied. And how to how to divide 25 by 5. This is the way 25 by 5. Okay. And then if we want to do in here 25 by 5, then we can write here also, for example, right here, basic 26, find the square of 7, which is 20, problem number 26, basic 26, I will find basic 22, 23, 24. This is a 24. Find the square of 7. So basic 24. Find the square of 7, which we could do by 7. If you put a 7 and then square root of 2, if you write this, so we are not getting the results in this format. Okay, 7 square. How can we do that? We have to find that. And then if you write it in here, this is all. This is what. So this is what you can find the square of a number in Python. If you take out this parenthesis and then write it, you can get the same results. So that is the way you can write the exponentiation of a number. Okay, so we have done few things. Now let us do, I want to find the exponentiation of a number, e to the power 4. E to the power 4 could be found like that way. NP is a package which you need to use. If you write just exponentiation of 4, exp of 4, you will not get the result. Take a look at that. You are not getting the result. So you have to write NP. Similarly, if you write here log of 34, you will not get any result in here. However, if you write this, then you will get the result in there. And this is the trigonometric function sine theta, which you will get like this. Okay. Now, I want to enter a small data set in Python, which I can do. I can do a small data sets in Python, which we can do by running this. So this data has been entered. Now, if you write like this way, after entering the data, we want to convert the data. So as a data frame format, we want to convert the data as a data frame format. So the Data one is the data that I entered in the Python by putting square bracket and comma between numbers. I got the name of the data, which is some numbers, and name it as a data one. But from this data one, if I want to get some desired output, we have to transform this data one as a data frame format. So I converted it by the data frame format on line number 22. So now if I want to find DF is the data frame format of the data one. Now if I want to find the describe, I got the count. How many observations in there? 30 observations. What is the mean of these 30 observations? 35. What is the standard deviations of these 30 observations? Is 10. What is the minimum? What is the first quartile, second quartile, third quartile, or 25th percentile, 50th percentile, and 75th percentile, and maximum? All of these things could be obtained easily by using df.describe. Okay, now individually, suppose I want to find the mean of this data. So this is the way you can find the mean. And individually, suppose I want to find the standard deviations. This is the way we can find the standard deviations. And we can also find the variance. Find the standard deviations and variance of these data sets, of this 30 data points. So if we write here the variance on, we got that is the variance. Now I want to do some plotting. So as our data one or DF is a quantitative variable, so for the quantitative variable, two important graphs are histogram and box plot. We want to do these things, but in order to do the histogram and box plot, we have to import a package. The name of the package is matplot library dot pyplot as plt. So this is the complete library. This is the complete library, and I imported it with a short name plt. Plt as a short name. This name could be anything that you will put. You can put any name in there. Okay. After these things now come in here. After these things come in here, plot. This is called the histogram that we created. Now I want to create a box plot. This is the box plot that we have created. So if you do the histogram and box plot side by side, you will get the complete pictures of the, variable. Okay. You will get the complete pictures of the variable. Now I want to do side by side. That means box plot and histogram I want to have side by side. So what I should do, this is called the, this lines of code, line starting from 36 ending in 43. These lines of code will be run simultaneously so that we will get side by side box plot and histogram. So now if you take a look at the line number 36, it is mentioned plt plt, which is the short name of the library matplotlib.pyplot, and then I put the subplot 221. So that means I am putting here 2 rows, 2 column first figure, 2 rows, 2 column second figure. That is the way it is written. So if I run it, we will got these things. 2 rows. If I write it in here in this format, if I want to change it like this, 221, 211, and 212. 212. If I run this, take a look. If I change like dimension of the graphing parameter, it looks like this. See, if I change this, so 2 row, 1 column, 2 row, 1 column, 1 figure, 2 row, 1 column, second figure. So that means 2 row, first row, second row. And this is only 1 column, figure 1, figure 2. So that is the explanations. I can write here 2 row, 1 column, 1 figure, 2 row, 1 column, second figure. Or I can write here by this format as well. It will be side by side instead of up and down. If you run this side by side, two figure. Okay. So now we learn how to do box plot and histogram side by side. So from box plot and histogram, we will get the complete picture of a quantitative variable. So now I have to explain what is meant by the complete picture. Complete picture means if you have a quantitative variable, you need to know minimum, maximum, first quartile, second quartile, third quartile, and then outliers. These six things you can get from the box plot. Why? So this is the any points that fall outside this lower uh, maybe whisker and outside this upper whisker, that is called the outlier. And then also that value is called the minimum and maximum value. And this is the first quartile, second quartile, third quartile. So from the box plot, we know six quantity: minimum, maximum, first quartile, second quartile, third quartile, and outlier. So these six things we can know from the box plot. And from the histogram, we know the model class. Model class is the class that has the highest frequency. So this is the model class. This is the model class that has the highest frequency. The bar is highest in here. And from this histogram, we also know the shape of the distribution, whether it is symmetric, it is left skewed or right skewed. Okay. After this, now I want to enter a qualitative data. So this is the qualitative data I entered in Python with a quotation mark. The letter L stands for Latino. Maybe A stands for African American, something like that. Or maybe E stands for European and N stands for North American, something like this. So the letter L stands for Latino, N stands for North American, A stands for Asian, and then E stands for European. This is the way I enter a race data of few people. So I entered the race data of the few people in here. So maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 persons and their associated race have been put in the data2 variable or data2 object, whatever you can call. And then L stands for Latino, N stands for North American, A stands for Asian, E stands for European. So this is a race data of 20 persons. And now I want to do some kind of plotting for this qualitative data. So I first import a package known as the import collections. This is the package I have imported. After doing that, I want to see the frequency. In order to do the frequency, I have found this. I have computed this, and then I write in here DICT and frequency. So collections.counter data has everything, and then I put here Dix frequency. Then I found that there is 5 Latinos, 4 North American, 4 Asians, and 7 Europeans. That is the way you have to explain this qualitative variable. After doing these things, I want to draw a bar chart for this qualitative variable. Remember, for the qualitative variable, two graphs: bar chart, pie chart. Bar chart, pie chart for the qualitative variable. And for the quantitative variable, most important chart are box plot and histogram. Okay, so let me run this one first. I run this one. I got this bar chart, and Latino is 5, and North American is 3, and European is 7. If you go up, European is 7. That's the way you will get the bar chart. Previously, we got the frequency. Here we got the frequency. Now we represented that frequency in the format of a graph so that it is easily visualized and immediate decisions could be made by looking at the graph instead of looking at the number. Okay. Now, if I want to do the pie chart, I have to run this line of code, then pie chart. This will be the pie chart. Let me explain these things to Perl.bar. X and Y I have declared in here. X is the level, Y is the frequency, and then I plot it. The title, and this is the x-axis level, this is the y-axis level. So each line of code If you have a problem, you can ask me. I can explain to you by email. Or if you just run the code and take a look at the output and then match those things with the line number 55, 56, 57, you will understand what line of code is doing, is putting labels in the x-axis and y-axis and also titles of the graph. Similarly for the pie chart. Now I want to do bar chart and pie chart side by side, which I can do by running this line of code. Let me see why I'm not finding these things. Okay, you have to run it like entire things. I did not run completely. This is the bar chart and pie chart side by side. Okay, so now I want to explore something in here. What does explode means? Explode means if you put the explode, the each slide of the pie chart will be separated from the others. For example, let me run these things. Let me run these things. Are you seeing it is exploding? So this blue part is separated from this yellowish, and then from this red, and this green is separated from the yellowish and yellow and red. Okay, so that could be obtained by putting this explode. If you comment this out, if you put the hash, then it will be commented out. And then if you take that part out, let me just copy these things and then put it in there and take out this explode part completely and also put a. So what happened? I commented out these two lines, 62 and 63. Now I want to, and I copied the line 63 and in line 64, just taking out explode part. And then if I run this, you will see the separation part will be gone. So this is the pictures. So I hope you understand the meaning of this. If you take out these two, then you have to commentate that one. So if I want to take the comments out from there, then I have to put that one back. So now if I run it, you will see again the graph will be separated. Slices will be separated. So that's the meaning of the explode part. Okay. So now simulations for empirical rule. Okay. That is an important concept. I need to clarify what is the empirical rule. So empirical rule, in order to explain empirical rule, I have to draw some figure. Let me take my board. Here is my writing board. Here is my writing pen. And here is my board and writing pen. I entered in there. Now I want to open a new. As you have seen, I put a Word document where I want to write something. So for example, if I want to go there and take this, I'm going to explain what is empirical rule. So this is the histogram I have constructed from the quantitative variable. I have constructed histogram from the quantitative variable. Very bad drawing. Okay, so now if I add the top middle point of each bar by a smooth curve like this, so we got a curve. Okay, so now how it is computed? Suppose this is 0 to 10 to 20 to 30 to 40 to 50 to 60 to 70. So 30 to 40 has the highest number of frequency. So that is called the model class, MC. This is called the model class. Model class. The word model coming from the word mod. Mod means what? Highest number of frequency. So now, if you have a quantitative data, from the quantitative data, if you construct a histogram, after constructing the histogram, if you add the top middle point of each bar by a smooth curve, then you will get a frequency curve. This is called the frequency curve. This frequency curve you will got directly from the histogram. Remember, frequency curve you obtain from the frequency bar. That means histogram. So you have a histogram, you add the top middle point of each bar, and then the curve that you obtain, that is called the frequency curve. Remember, histogram is constructed for the quantitative variable. And from that histogram, if you add the top middle point of each vertical bar by a smooth line, and the curve that you obtain, which is looks like this one, this is called the frequency curve. Frequency curve. Why frequency curve? Why it is named frequency curve? Because this curve is obtained by adding the top middle point of each frequency bar from the histogram. This is called the frequency curve. Okay. Now you understand how frequency curve is constructed. Now, if the frequency curve look like symmetric, now I'm not going to construct histogram. Instead, I directly construct the frequency curve. If frequency curve looks like symmetric, that means this is the point where mean equal to mod equal to median equal to median. Then this curve is called the symmetric frequency curve. Symmetric frequency curve, or it is called bell-shaped curve. Bell-shaped curve. Symmetric frequency curve, bell-shaped curve, mount-shaped curve, frequency curve, bell-shaped curve, mount-shaped curve, mount-shaped curve, symmetric curve, bell-shaped curve, mount-shaped curve. This is the curve is known. Okay. So in such a cases, suppose this is the mean. Suppose this is the mean or median, which is known as the mu. Okay. In these data, this is called the mean. And then these data will also have a standard deviation. These data will also have a standard deviation. Suppose that standard deviation is known as the sigma. Okay. So again, this frequency curve is obtained from a data. That data we partition into class interval 0 to 10, 10 to 20. And within one class interval, how many frequency fall in this case? For example, 0 to 10, 0 to 10. So this is a class interval and this is a frequency. 0 to 10, suppose 2. And then 10 to 20, suppose 5. And 20 to 30, suppose 7. In that way, frequency fall. Now, 10 will be considered, will not be considered in here, 10 will be considered in there. 20 will not be considered in here, 20 will be considered in here. This is called the lower limit inclusive class interval and upper limit excluding class interval. Upper limit will not be included in this case. 20 will be included, 10 will be included in here, 20 will be included in here. All other values from 0 to 9 or 9.999, everything will be included in here. In this way, we got this frequency curve. And if this frequency curve look like symmetric, then half of it in the left side, half of it in the right side, from the mean, and then mean, median, mode are same in this line, then this is called the symmetric curve, bell-shaped curve, or mound-shaped curve. Okay, symmetric curve, bell-shaped curve, mound-shaped curve, or normal curve, or normal curve. Okay, so this mu is the mean of this data, and this sigma is the standard deviation of this data, mean. So empirical rule is telling you within one standard deviation, we need within one standard deviations. This is the mean, and this is the mean minus one standard deviation. This is mean plus one standard deviation. Within one standard deviation, if your curve is symmetric, 68% data false. Okay. Within two standard deviation, let me take different color. Within two standard deviation, which is equal to mu minus 2 sigma and mu plus 2 sigma. Within two standard deviation, 95% of the data false. 95%. That color is so big. So within that, 95% data false. And then within three standard deviation, so mu minus 3 sigma, and within three standard deviation, mu plus 3 sigma. Let me take another color, another red, not red color. I want to take another, suppose purple color. Within this, 99 point, let me write it in here, 99.7% data false. 99.7% data false. Okay, that is called empirical rule. That is called the empirical rule. But when you can apply empirical rule, you can apply only empirical rule if you have a quantitative variable. From that quantitative variable, if you draw a histogram, after drawing the histogram, if you add the top middle point of each vertical bar, and then the curve you obtain by adding this top middle point of this vertical bar, that curve will be called symmetric or bell-shaped or mound-shaped or normal curve if it is 50% of the frequency to the left and 50% of the frequency to the right of the mean, median, mode, and mean, median, mode coincide. That means they are the same values. So if the visual inspections, if the curve look like symmetric, normal, bell-shaped or mound-shaped, then it is called the normal curve, bell-shaped curve, mound-shaped curve. And in such cases, within one standard deviation, 68% data false. Within two standard deviations, 95% of the data false. And within three standard deviation, 99.5% data false. Okay. So now let me insert another blank page. I want to now discuss Shabby rule. Okay, let me take you to the code. Here, I put here, take a look at that. This is the data. I put mu equal to 50. That means mean 50, standard deviation 10, and B equal to 100. And then I want to simulate the data from a normal distributions, line 90 to 94. So this is the data that I have generated in here. Okay. So in this data, sorted X, if you take a look at the sorted data X, and then if you want, we can also do histogram to show you that these data, here is the histogram. Let me put these things in the format of a histogram so that you can visualize these things. Control V, and I want to put here X, and let me check whether this X is a big X. I have to change it to a small X, and then I want to draw this curve. Are you seeing? So this looks like a symmetric. This looks like a symmetric, half of it in here, half of it in there. This is the highest class, model class. This data looks like a symmetric data. So now, as the mean is this, what percent is? 68% data fall within one standard deviation. So I have computed these things. So 40 to 60, 68% data fall, 40 to 60. Now I want to make sure that 68% data falls between 40 and 60. How can I do that? I have to do that by going there, 40 and 60. 40 and 60. Are you seeing 40 and 60? Because this is one, this is the mean, this is the minus one standard deviation. This is the mean, that is the plus one standard deviation. Mean equal to 50, standard deviation equal to 10. Take a look. This is the mean and this is the standard deviation. So let me comment it in here. This is called the mean, and this is called the standard deviation, Okay, this is the mean, this is the standard deviation. And now within one standard deviations, that means 40 to 60. If you subtract the one standard deviation, add the one standard deviation, lower limit is 40 and upper limit is 60. I want to compute among this number whether 68% of those falls in there, come in there. It starts from there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73. So that means 5 more observations. So among those 100 observations, 73 of those observations fall within one standard deviations. Okay. So we said that approximately 68%, right? So 73 is approximately to 68%. Now we want to check second one. So we have seen there is 73. Now we want to, so 59, so 59 is 73. So, and then we will count below 40 and above 60. So there is 73. Now let us compute that one. That one 30 to 70, right? 30 to 70. So let us compute 73. Then we will start adding. So 73. So 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85. This is the 85. 85, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96. 95. Exactly 95. So our range was 30 to 70, right? Our range was 30 to 70. 30 to 70, we found exactly 95%. And then remaining one, 99.9%, we will get between these two, 20 to 80. And then 20 to 80, if you find here, it will start in here and go all the way up in here. 20 to 80. 20 to 80. So 98 of the data points fall 20 to 80. Where is 20 to 80? This is 20 to 80. So approximately. So now let me again explain you before going to the next topic. Suppose you have a quantitative variable. Quantitative variable could be numerical variable with decimal number, without decimal number. Okay. For example, number of accidents, number of traffic accident, number of phone call. This is a quantitative variable. On the other hand, height, weight, this is also quantitative variable which have decimal points. So if there is a quantitative variable, best way to visualize that quantitative variable is to draw histogram and box plot, which will give you complete picture of a quantitative variable. So that means from that plot, you will know 8 things. What are the 8 things you will know? You will know minimum, maximum, first quartile, second quartile, third quartile, outlier, model class, and shape of the curve, whether it is symmetric or non-symmetric. Okay. So non-symmetric means skewed to the left, skewed to the right. What is that one? Either you will get symmetric curve like this from the quantitative variable, sorry for the bad drawing, or you will get skewed to the left or skewed to the right. This is the skewed to the right. Long right tail. This is called the positively skewed. And this is called the long left tail. This is called the negatively skewed. Positively skewed and negatively skewed. Positively skewed and negatively skewed. And this is called the symmetric. Okay. Now, for this symmetric, we know the empirical rule from where we can compute different percentage of frequency falls within 1 standard deviation, 2 standard deviation, and 3 standard deviation. If our frequency curve is not symmetric, that means positively skewed and negatively skewed, what percentage of data falls within 1 standard deviation, 2 standard deviation, 3 standard deviation? That is called the Chebyshev rule. Chebyshev rule. That is called the Chebyshev rule. Okay. That is called the Chebyshev rule. So we are going to discuss the Chebyshev rule now. Now, again, I'm telling you, if you have a data, from that data, if you construct the histogram and add the top middle point of each bar and got a frequency curve, that frequency curve does not look like symmetric, mound shape, bell shaped, or normal. Instead, it looks like the curve has a long right tail or long left tail. That frequency curve is called the skewed curve. It is called the right skewed or positively skewed if it has a long right tail. It is called the left skewed or negatively skewed if it has the long left tail. So positively skewed, this is the rule. Positively skewed, long right tail, and negatively skewed, long left tail. In such a case, this is the highest frequency, highest peak. This is called the model class. This is called the mod. This is called the mod. And in such a case, median is always in the middle. And this is called the mean. Mean. Why the curve looks like that way? I'm going to give a realistic example. This is called the mod. Highest frequency lives in here. Mod. This is called the median. Median is always in the middle. And that is called the mean. Mean. What percentage of data fall? The rule is 1 minus 1 over k square. At least 1 minus 1 over k square percentage of data falls within within K standard deviation. So that is the explanation. What percentage of data fall within 1 standard deviation, 2 standard deviation, 3 standard deviation, 4 standard deviation, 5 standard deviation, if the frequency curve is skewed to the right, which is known as this one, skewed to the right, skewed to right, or positively skewed. This is called the skewed to the left, skewed to left, which is known as the negatively skewed. What percentage of data fall within 1 standard deviation, 2 standard deviation, 3 standard deviation? The answer is 1 minus 1 over k square. K is what? K is number of standard deviations. Okay. So now I want to give you a realistic example why mean is in here, why median is here, why mod is in here. Okay. Mod is that number which has the highest frequency, and that class is called the model class. Since it has the highest frequency, so mod is in here. So their high peak, there is the mod. High peak, here is the mod. Median is always in the middle. Okay. Median is always, there is no way. Why mean is in the right? Suppose I want to take a data from a small city like Muncie, Indiana. Muncie, Indiana. Muncie, Indiana. So Ball State University is in there. I went there. So the city is very small town based on Ball State University and Ball Memorial Hospital. These two are the main employers of the peoples of that city, Muncie. So I am collecting data from the Muncie, and the average income of the people is 50,000, 60,000, 70,000, something like that. That is because of a small city. Okay. So I have taken a sample of size, suppose 100 people. And in that 100 people, suppose a mega rich person who is included in the sample. A mega rich person who is making maybe $1 million or $10 million or $12 million a year. $12 million. One person is included in that sample. Most of the people are making 40, 50, 60, 70, 80,000, but a 1 or 2 persons who had a very high income, they are included in the sample. So what happened? Because of these ultra rich people, the average will go up. So that is why this mean is in the right. So this is, suppose mod equal to 10, median equal to 15, and then mean will be 25. How these things happen? Because most of the people's income is 40,000 to 70,000. Couple of million people are included in the sample. So that is why the yearly income went up to, so this is 100,000 yearly income. This is 150,000. But because of couple of millionaire are included in the sample, so it went up to that. For example, maybe it is a 70,000 or maybe 80,000 is the median, but when those rich people are added, so yearly income went up to 100 million. Okay, that's the way. So now, what is this type of example? This type of example, suppose Beverly Hill area, Beverly Hill, where all celebrities lives there, their yearly income is a minimum of $1 or $2 million. So that is why this is $1 million, $2 million. But accidentally in the sample of size 100, you included couple of plumber, couple of Uber driver, couple of Lyft driver, and couple of like the land mower or landscaper you have included. So what happened? This is $1 million people who lives in Beverly Hill, because you included low income people in the sample. So they help to went down the average income. So that is why mean went down. Suppose this is a 1 million, and the median is suppose 750,000 median income. 1 million is the highest medium. And because of some plumbers and Uber drivers and some others, so it went down to 250,000. Okay, so that's the way you will end up with this. In such a cases, your rule is this: 1 minus 1 over k square. Now, At least. So let me write it in here theoretically so that you will understand what does this mean. Within one standard deviation, within one standard deviation, what percentage of data fall? 1 minus 1 over 1 square. So which is equal to 1 minus 1 equal to 0. So within one standard deviations, no meaningful uh, results. Okay, 1 minus 1 over k square, that was a mathematically proved Chebyshev theorem. Okay, that is not like I just put 1 minus 1 over k square. K is the number of standard deviations. That is mathematically proved by famous mathematician, statistician Chebyshev in Russian. Okay, so now within two standard deviation, what percentage of data fall? 1 minus 1 over 2 square, which is equal to 3 over 4. 3 over 4 equal to 75%. At least 75% of the data fall within two standard deviations. Within three standard deviation, 1 minus 1 over 3 square, which is equal to 8 over 9, which is equal to 89%. At least 89% of the data falls within, at least. Remember the word at least. At least. At least. At least 1 means what? At least 1 means greater equal to 1. At best 1 equal to 1. At best 1 equal to 1 less equal to 1. This is called the at best or at most. This is called the at least. At least 1. I need at least 2 apple. I need at least 2 drinks. Okay. So remember the word at least should be in there. So that is the way Chebyshev rule are explained. After doing theoretical explanation, let me go for coding. So I put here simulation for empirical rule. Empirical rule means symmetric curve, bell-shaped curve, or mount-shaped curve, and you are finding the percentage of frequency falls within one standard deviation, two standard deviation, three standard deviation from mean. Chebyshev rules means percentage of frequency fall at least percentage of frequency fall within one standard deviation, two standard deviation, three standard deviation. So I created a data from there and then bootstrap this. I created this exponential data and sorted this. After sorting this, I put these things in the format of a hist, Paul.hist, and I put here y, and then I put like this. This is histogram. Are you seeing long right tail, So that is the simulation is coming from exponential distributions. Previously, it is coming from normal distributions. These are, so these things, it is a mathematical distribution. Mathematical form is in there. Mathematically, these things can be expressed from that distributions, mathematical distribution, which has a function which is known as the PDF. And this is also PDF, probability density function, which is known as the change of rate. From there, we simulate the data. After simulating the data, after generating the data, I did the histogram in order to convince you that the curve is skewed to the right. Now, if I want to compute within one standard deviation, two standard deviation, three standard deviations, we got these results. Okay. Okay, what is the that is not right. So we have to find np dot average y, and then np dot std y, mean and standard deviation. Let me check in here again. np dot std, np dot average, np dot average. Okay, so I created these things. Or is that one? This is my A, and that is my B. I computed these things, A and B. This is my A, and that is my B. And now I have to find it in here. A 1 times. After doing this, you have to find what percentage of data falls within 1 standard deviation. So that is, I have to write here, no meaningful. I keep it blanks because no meaningful results is in there. Second one is um, within at least two standard deviation. So our A minus 2 times B, and then A plus 2 times B. This is what we got. This is what we got. Okay. Within mean 2 times standard deviation 2 times. So in this case, we can also write these things, but there is no A minus B, and A plus B. Okay. So now I said 75%, right? So 75% data falls within 2 standard deviations. So let us do these things. We got negative 3.34 to positive 11.21. So now let us check the shorted one, at least 75%. So come in here, at least 75%, right? Negative this to 11 point this. So at least 75%, that means it could be more than. So let us go, all of this is included because this started from negative and we want to stop in 11.22. 11.22. So we are stopping in here. So that means at least 75% means only 4 data points are not included within that interval. So remember, I wrote here very clearly, at least 75%. So which is true from there because only 4 of these 100 data points does not include these values, that highest value and lowest value. Come in here again. Highest value is 11.22. I have to stop in here. And beginning from the top, so that means 96 of the 100 data points fall within 2 standard deviation, which matches the claim that at least 75%. Okay. That's the way we have computed Chebyshev rule, empirical rule. And then now this is called the covariance. How to compute covariance? Covariance means joint variability. Suppose supply is low, and in that case, price will be higher. So that means they are opposite way correlated. Opposite way means one is increasing, other is decreasing. Supply is decreasing, price is increasing. And supply is increasing, and then supply is increasing, price is decreasing. Demand is increasing, supply is decreasing. So more and more people are now consuming rice. So that means rice supply will be decreased. something like that. If all over the world, people start eating rice 4 times in a day, 3 times in a day, for the morning, from breakfast, from lunch, from dinner. So that means the wheat and other productions demand will go down. Supplies will go up, or supply will go down as demand is increasing, something like that. So covariance means joint variability. One increases and other increases, or one increases, other decrease. So which can be computed X and Y. I previously computed. X is computed from normal distribution simulations, and Y was generated from the exponential distribution simulations. So this is the covariance. So this is called the variance of X. This is called the variance of Y, variance covariance matrix, and this is the covariance of X and Y. Okay, this is covariance. This is the variance formula. This is the variance formula, and this is the way you can find the square of a values. Okay. So this is now done. Let me save this file. Save as. I want to do these things in WSUV week 1, basic Python basic computation part 1. Basic computations part 1. Basic computations part 1. Okay, basic computation part 1. So now I am going to stop sharing. And then I want to